Page 3. So we have 2 logs here equal to a number, so we want to put the logs together. So we're going to get log, and the sum of 2 logs becomes a product, x times x plus 21 equals 2. And now, since the x's are inside the log, or base of the log, in this case inside, I'm going to change it to a power. To what power did I take 10 to get this? And it's 2. So 10 to the 2 is x squared plus 21x. I recognize this is a quadratic. This is 100, so I'm going to subtract it so they get equal to 0. X squared plus 21x minus 100. That factors, or you can use the quadratic formula. That's x plus 25 and x minus 4. And so x equals negative 25, or x equals 4, and negative 25 would cause problems. Can't have a log of a negative. X equals 4 is doable and is the correct answer. And you can plug it into your calculator to check it if you would like. Number 4. Assume there is radioactive material and it decays according to this. Determine if 10 grams decays to, and this is supposed to be years. I think all this was supposed to be in years. So this is years, I said. 10 grams decays to 2 grams in 50 years. So goes to 2 grams, so that's the amount left is the starting amount. E to the k, and the number of years was 50. So to solve for the k, which is in the power, I'm going to divide by 10 and get 1/5 equals e to the 50k. Then write this as a log, so ln 1/5, I'm doing natural log because the base is e and that's base is e, equals ln of this turns into 50k, because this says to what power do I take e to get 1/5? E to the 50k equals 1/5. So then I divide by 50, and k will equal ln 1/5 divided by 50. And if I pull out my calculator and figure that number out, I get ln 1 divided by 5 divided by 50. And I get the approximate value of k of negative 0.0322. How much of 15 grams is still radioactive after 5 years? Well, I'm just going to change the starting amount to 15. So it's going to be 15 e to the negative 0.0322, and after 5 years times 5 to find out how much is left. So I'm going to take the answer I got here. I'm going to store that in x so I have it for later. So I'm going to take 5x, e to the 5x, e to the 5 times the number I stored there, that number. And then I'm going to take that whole thing times 50. And I get 12.77 grams. How much, in how many years will 20% be still radioactive? Well, if I went from 10 to 2, that is 20%. It'll be 50 years. But we could also do it, if you didn't catch that, if I'm going to go to 20%, this would have to be 0.2. So I'm really solving the equation. 0.2 equals e to the negative 0.0322t. So I would do ln, rewrite this as a natural log. ln 0.2 divided by negative equals negative 0.0322t. So then I would divide by that. So it's going to be ln 0.2 close parenthesis divided by negative 0.0322, and that comes out to almost 50 years. If I would have done that with the x, it would come out to be exactly 50. So 50 years. D, what's the half-life? So that's one, how long does it take to come half as much? So this part would have to be 0.5. So to get that to be 0.5, I would change it to ln. So I'd have ln of 0.5 equals negative 0.0322t, and it divide by that. So it's going to be ln 5 on my calculator, since I stored that in a coefficient in x, it'd be ln 0.5 divided by x. That's the negative 0.0322, and I get 21.5 years. Okay, and another one, we have $600 invested at 4%. So how much is in the account after 10 years? So we got the amount left is equal to $600. E to the interest rate, which is 0.04 times t, which we're going to make be 10. So I got to just type that in. 600 e to the 0.04 times 10, which is just 0.4, is $895, approximately $895.09. How long would it take to be 1,000? So we want 1,000 to equal 600 e to the 0.04 t. So I'll divide by 600 first, and 1,000 divided by 600 is 0.1666 is, yeah, 1.666 repeating equals e to the 0.04 t. So I'd write it as an ln. So to what power do I take e to get 1.666 repeating equals 0.04 t. So I got to divide ln 1.66 is repeating by 0.04. So I got to take ln of my answer of 1.66 repeating divided by 0.04, and I get 12.77. $12.77 years, it'll be up to balance of 1,000. How long for the balance to double? So that means this has to be 2. We can divide, this would be, you could do it with 1,200 and 600, and 6 into 12 would be 2, and so this has to be 2. So we're going to have 2 equals e to the 0.404 t. So I'll take the natural log, and we have a natural log of 2 equals 0.04 t, and we divide ln 2 by 0.04. So ln of 2 divided by 0.04 is 17.3233 years. Okay? And that's page 3.